this video, I will be placing rebars in these two foundations that you are seeing on screen and that have already been created, and I will set up a nice looking shop drawing with a complete bending schedule. But before we get started, let me quickly talk about my Revit Reinforcement Mastery course. This is a complete course that covers every rebar tool in Revit, showing not only how they work, but also when to use them. I demonstrate the full workflow, from placing reinforcement in all kinds of concrete elements, setting up bending schedules, and producing clear, professional shop drawings. The course also includes a downloadable Revit file with all schedules, view templates, and a fully organized project browser. If you want to take your reinforcement skills to the next level, follow the link below. Now, back to the video. Let's start by applying an already created 3D rebar view template to this view. This view will display all the rebars created, giving us a full overview when placing rebars. To organize my views, I will, in the Properties menu, place the view in the section Foundation. The sorting parameter is a project parameter created for this project. By placing each view in a clearly named folder, both the project browser and the project itself stay well structured. All views related to the foundations are collected in the Foundation folder, making them easy to locate and manage. Before starting to place rebars, I want to set up a plan view and a section view, starting with the plan view. Hide all other concrete elements except the two foundations using the isolate command, and place the view in the foundation folder. This view will appear under the subcategory Structural Plans in the foundation folder. Moving on, I will copy an already existing foundation sheet and just edit the name to the foundation 3 and delete the schedule placed on this sheet. Since I copied an already existing foundation sheet, it is already placed in the foundation sheet folder. This is where an organized project browser really shows its value. When I need to drag the plan view onto the sheet, I can immediately find it, since I know where it is, because it's placed in the foundation folder under the plan views subcategory. After placing the plan view on the sheet, I adjust the scale so it fits the layout more effectively. I also adjust the crop region to display only one of the foundations, since I want to avoid repeating the same steps unnecessarily in this video. The process will be identical for both foundations. For now, I'll focus on just one. I will also need a section view of the foundations. So go to the view and then the section. Here, I will use the building's section rebar view, making sure all rebar section views end up in the same section rebar folder after naming it foundation in the sorting parameter. I will also edit the section name to section 1 foundation 3 and drag the view into the sheet. I will proceed to add the section rebar view template, and it introduces a few changes, most noticeably the rebar color. I turn the template off immediately, but the adjustments it made remain active. I'm doing this because I want to apply filters specifically tailored to this single foundation section view. In a larger project, I could have created a dedicated view template for foundation reinforcement, but since this is a small job, I won't add more templates. The filters I apply here will hide reinforcement in stairs, walls, and floors. Any remaining rebars that don't belong to the foundation will be hidden manually. I could create additional filters for columns and area reinforcement, but for this case, manual hiding is sufficient. Alright, with the views and sheets prepared, it's time to start placing the reinforcement. I begin in the plan view and activate the rebar tool. From the rebar shape browser, I select shape 21, a U-shaped bar. Next, I move to the top ribbon to define the placement settings, placement method, placement plane, orientation, and the layout rules. I set the maximum spacing for the rebar set here as well. All of these functions are explained in detail in the rebar placement section in the course. I then go to the plan view and hover over the foundations. Some rebars appear and when I click the left mouse button, the rebars are created. Once placed, I can see them in the 3D rebar view. They are placed a little bit wrong, but that can easily be fixed by pressing the spacebar a couple of times until the desired form is achieved. The rebar is also visible in the section view, where I will take a look at the constraints. We'll just adjust one of them so it is constrained to the rebar cover. The other seems fine. Constraining them might be important if you are going to propagate them to another foundation, which I will do at the end of this video. You can learn all about constraints in the course. The first rebar is placed in the plan view. I continue with the same technique used to place U-shaped rebars in the other directions as well. After it is placed, I change the bar diameter. I could have done it before I placed it, but the program is flexible. When I go to the section view, I can see that the newly placed rebar is positioned on top of the other rebar. This can be adjusted by just dragging the rebar, or, as I will do, editing the constraints. So I go into the edit constraint mode and start adjusting the distance to the rebar cover. Let's set it to minus 20 millimeters, and once I type it, the rebar is positioned just above the already placed rebar. I will do that on both sides as well, so the ends of the rebar do not collide. Also, the constraints on the top of the cover must be adjusted. Constraining all the rebars in the foundation is not necessary if you only have one foundation. It might be as simple as just adjusting them manually without going the constraints route. But if you have many foundations with different geometries, it might be worth the effort. All good. Hit the green check mark when done. 2 rebar sets are placed. Let's take a look at them in the 3D view. Change the template to be more up close. So far, it looks pretty good. So we are going to continue to place rebar sets. Now I will place them in the section view using the expand to host and an orientation perpendicular to cover. These rebars will be just straight rebars lying at the top of the foundation. And of course, we will need straight rebars in both directions. So we will place another set using the parallel to the workplane. The diameter of the top ones will be 12 millimeters in diameter. Moving on to the last rebars we will be placing, and those are the L-shaped rebars going from the foundation and up into the column. We'll quickly change the length parameter A since it is set to 2940 millimeters. It got an oversized length since I used expand to host instead of by 2 points as the placement method, but that is an easy fix. Also important to change the host for the L-shaped rebars because they are currently hosted to the column. With the wrong host assigned, they wouldn't be included when using select all rebars in host, which I'll use shortly. They also wouldn't be copied when using the propagate tool. So I changed the host of the rebars to the foundation. They are now properly constrained to the foundation as well, making the section view more appealing to look at and easy to distinguish the different rebars. All the rebar are placed. Now let's assign them a partition number. We'll pick one and go to the properties menu and change the partition to 3FO. Then use the select all rebar in host tool to select them all. Now you can see the importance of a correct host setup, and then change the partition of all the rebars in the host to 3FO. Moving forward to set up the bending schedule, I will copy an existing one and place it on the sheet currently containing the rebar for Foundation 2. This schedule is available in the downloadable Revit file. So to switch to the schedule to show newly placed rebars, I open it and go to Filters. In the top row, I filter this schedule on the partition 2FO, change that to 3FO, and all the rebar just created will appear in this schedule. The steps here are easy. Copy an existing schedule and change the partition, and you've got yourself a new schedule showing the rebars for the new element. Moving on to the final stage of the process of setting up a sheet for this foundation, and that is tagging every rebar, giving the necessary information about each rebar placed, such as the number of rebars in the set, bar diameter, spacing, and rebar number. I will be using the annotation tool multi-rebar, which will both provide a dimension line and a rebar tag, making the process more effective. However, this is a tedious process, tagging every rebar. In the future, I think shop drawings are going to be obsolete, making them unnecessary to make. The only thing that will be needed is a solid 3D model displaying every piece of information, and more than a traditional shop drawing would. But even though the tools are there, the transition is taking painfully long, with the construction industry resisting big changes. Important notice here at the end: some may find it unconventional to display rebars in a dark red color, but in my experience, it makes the drawing much easier to read and helps you understand the reinforcement layout more quickly. And I also do understand that every country has its own set of rules on how to produce and show rebars on a shop drawing. Even every firm has its own twist on things. Hell, even within the firm there are different people with different styles. These videos are meant for inspiration and not necessarily the only and right way to do it, so take with you what you find useful and implement it in your own practice. But most importantly, I think, is to keep it simple. It is a guideline I try to follow. Just keep everything as simple as it can be. There is no need to overcomplicate things. I can also set a rebar dimensions line and tag a rebar in two operations using the tag tool and the annotate tool. In Norway, we do use symbols to represent the rebar shape and layout, so I have created a family that contains the necessary symbols that can be toggled on and off depending on the rebar. Again, there is some manually tedious work to be done. The symbols make the shop drawing a little bit nicer and easier to read. I'll also tag the reinforcement in the section view. For this, I use the standard tagging tool with the hotkey TG. In the section, the tags will only show the partition and the bar number, nothing more. All other information is already provided in the plan view, and I avoid repeating details that would only add clutter. Keeping the section view clean and tidy makes it much easier to read. I'll also make a small adjustment to the bottom rebar set. By selecting the set and using edit bars, I can manually move or delete individual bars within the set. Here, I move two of the bars so they sit inside the L-shaped bars that continue up into the column. The shop drawing and the sheet are finished. Looks pretty solid if you ask me. Before wrapping up, there is one more operation to perform: copying the reinforcement to the second foundation, which has different dimensions, length, width, and thickness. For this, I use the propagate tool. I start by selecting all the rebars, then choose propagate and set it to align by host. The tooltip tells me to pick the destination host, which is the other foundation. Once selected, the reinforcement is copied over and automatically adapted to the new geometry. This demonstrates how crucial correct hosting and well-defined constraints are. When those are set up properly, the software handles the rest.